Hi everyone, I'm Shubham. I'm a master teacher at Vedantu. We are discussing JEE Advanced 2019 Paper 1 Mathematics, and the question for this video is this. Let L1 and L2 denote the lines r vector equal to I cap plus lambda times minus I cap plus 2 j cap plus 2 k cap. Lambda can be any real value, and r vector equal to mu times 2 I cap minus j cap plus 2 k cap. Mu can be any real value respectively. If L3 is a line which is perpendicular to both L1 and L2 and cuts both of them, then which of the following option or options describe line L3? There are four options and this is a multiple correct type question. Now first of the things that you should consider is how are these two lines L1 and L2 situated with respect to each other? Are these parallel lines? If they are parallel lines, then line L3 would be a set of parallel lines parallel to a vector parallel to the plane containing line L1 and L2 and normal to these two lines L1 and L2. If L1 and L2 are intersecting lines, then line L3 would be a line passing through the intersection point of L1 and L2 and parallel to the normal to the plane containing L1 and L2. And if L1 and L2 are skew lines, then L3 would be a line along the shortest distance between these two lines L1 and L2. So now as we look at the equations of L1 and L2, they are clearly not parallel lines. Why? Because the vectors parallel to these two lines, respectively minus I cap plus 2 j cap plus 2 k cap and 2 I cap minus j cap plus 2 k cap, they are non-collinear. Now they may be intersecting or they may be skew. Now how do we find what they are? We use this popular method, box product of a1 vector minus a2 vector, b1 vector, b2 vector. And if this box product turns out to be 0, then since these two lines are not parallel, they would be intersecting. And if this box product turns out to be non-zero, then these two lines would be skew lines. Now what is a1 vector, a2 vector, b1 vector, b2 vector? a1 vector is the position vector of a point on line L1, a2 vector is position vector of any point on line L2, b1 vector is a vector parallel to line L1, b2 vector is a vector parallel to line L2. So let's check it out. So I can say a1 vector is I cap and a2 vector is, you must even consider origin. So basically a1 vector minus a2 vector, considering this, row 1 I can write like this, box product can be written as a determinant, b1 vector corresponding to it I can write this row, and b2 vector corresponding to it I can write this row. And what about this determinant? The determinant turns out to be 6, which is non-zero. So that means these two lines are skew lines. Now since these two are skew lines, as we have already commented, line L3 would be along the shortest distance between the two lines L1 and L2. So it will be a unique line which, let's say, passes through point A on line L1 and point B on line L2. So coordinates of point A on line L1, I may consider it to be 1 plus 1 minus lambda, 2 lambda, 2 lambda. And coordinates of point B on L2, I may consider it to be 2 mu minus mu 2 mu. Now from here on, there are different possible ways of solving. Let's discuss two such ways. So in both the ways, we will anyway be considering vector AB vector. So AB vector would be what? You may say it will be 2 mu plus lambda minus 1 I cap minus mu minus 2 lambda j cap, 2 mu minus 2 lambda k cap. So let's discuss method 1. Here we may say that AB vector, since it is along the shortest distance between line L1 and L2, it will be perpendicular to the vectors parallel to the respective lines. So its dot product with those two vectors would be 0. So as you solve, you get minus times 2 mu plus lambda minus 1 plus 2 times minus mu minus 2 lambda plus 2 times 2 mu minus 2 lambda is equal to 0. And as per the second equation, it becomes 2 times 2 mu plus lambda minus 1 minus would become plus mu plus 2 lambda plus 2 times 2 mu minus 2 lambda equal to 0. Now as you solve these two equations, you would get lambda to be 1 by 9 and mu to be 2 by 9. Solving these two is simpler than what you may think. Here in the first equation, mu terms cancel out, minus 2 mu plus 4 mu. So essentially what you get is 9 lambda equal to 1. Lambda is 1 by 9. And similarly in the second equation, lambda terms cancel out, 2 lambda plus 2 lambda minus 4 lambda. And you get mu to be 2 by 9. Now having got lambda and mu, you may find the points A and B. So point A would turn out to be, as you may see, you put lambda to be 1 by 9. It becomes 8 by 9, 2 by 9, 2 by 9. And point B, as you put mu to be 2 by 9, it becomes 4 by 9, minus 2 by 9, comma 4 by 9. And also, you can get AB vector, which essentially is a vector parallel to line L3. It turns out to be, as you put values of lambda and mu, you get AB vector is, you can check, 4 by 9 plus 1 by 9 minus 1. So essentially it becomes minus 4 by 9. Similarly, you may say minus 2 by 9, minus 2 by 9, minus 4 by 9. And here you may say 4 by 9, minus 2 by 9. So you may say 2 by 9. Effectively, you may say a vector parallel to line L3 is, you may say, 2 comma 2 comma minus 1, basically 2 I cap plus 2 j cap minus k cap. Now using this, you may find the equation of line L3. So as we check with the options, mind it, a vector parallel to the line L3 is 2 I cap plus 2 j cap minus k cap. And point A is this, point B is this. So as we check the options, 2 I cap plus 2 j cap minus k cap, this vector parallel to line L3, it's same in all the four options A, B, C, D. So what we have to check is whether these points lie on line L3 or not. Yeah. So if you see carefully, 8 by 9 plus 2 by 9 plus 2 by 9. 8 by 9 I cap plus 2 by 9 j cap plus 2 by 9 k cap. 8 by 9 comma 2 by 9 comma 2 by 9. This is essentially point A only. Similarly, point B, 4 by 9 minus 2 by 9, 4 by 9. 4 by 9 I cap minus 2 by 9 j cap plus 4 by 9 k cap. So that means A and B options are correct. Let's check C option. Here in C option, the j cap component is not there. So is this point lying on line L3? Let's check. For example, you may consider this B option, this equation, and let's try to make the coefficient, so to speak, of j cap 0 by appropriately taking the value of t. So here I am having minus 2 by 9 j cap. So I'll take t to be 1 by 9 so that it becomes plus 2 by 9 j cap and it vanishes. Now what about I cap and k cap components? So here you get 4 by 9 plus 2 by 9. So it becomes 6 by 9, which is 2 by 3. Okay. K cap component 4 by 9 minus 1 by 9, which is 3 by 9, which is 1 by 3. So that means even C is correct. Clearly D would be wrong. Why? Because as I am making, the J cap component 0, I am getting I cap component to be 2 by 3 and K cap component to be 1 by 3. That means this point lies on the line and origin does not lie on the line. Why? Because in origin, I cap, J cap, K cap, all components you may say would be 0. But when I am making J cap component 0, I am not getting I cap and K cap components to be 0. So that means my answers are A, B and C. A, B and C. So now let's explore an alternate method. Here again I would need AB vector, which I have already written. And I would say, since AB vector is a vector parallel to the line which is normal to both these skew lines, AB vector would be collinear with the cross product of these two vectors, which are essentially respectively parallel to these two given skew lines. So what about cross product of these two vectors? You may say I cap, j cap, k cap, minus 1, 2, 2, 2, minus 1, 2, and it essentially becomes, if you see carefully, 6 I cap plus 6 j cap minus 3 k cap. Or essentially you may say AB vector is collinear with 2 I cap plus 2 j cap minus k cap. Since AB vector is collinear to this vector, you may say the ratios of the I cap, j cap and k cap components would be equal. So you may say 2 mu plus lambda minus 1 divided by 2 is equal to minus mu minus 2 lambda by 2 is equal to 2 mu minus 2 lambda by minus 1. Now again, these are essentially two independent equations, solving which you would get lambda to be 1 by 9 and mu to be 2 by 9. You can check it out. Now here, since I already have a parallel vector, just to find equation of line L3, I may just find one of these two unknowns, lambda or mu, and hence find one point, be it A or B, and get the equation. But here we are solving a multiple choice, multiple correct type question, where we may want to explore the other points also. So why not first explore the points corresponding to this value of lambda and this value of mu, all the first. So here, as we have already seen, the points will turn out to be A and B, 8 by 9, 2 by 9, 2 by 9, and B point 4 by 9, minus 2 by 9, 4 by 9. And also, the third option you may check by, making the j cap component 0, and hence you would ultimately again get the options A, B, C as correct options. So these were the two ways of solving this question. I hope you enjoyed it. Thanks for listening. Stay tuned for the next question.